Welcome back. We are continuing our discussion on calculus, where we are looking at gradient at a point, gradient of a function at a point. Our earlier example, we looked at gradient of a curve at a point. Now, when you are looking at the gradient of a curve at a point, as usual, we said you need to differentiate. When you differentiate, you get the gradient formula. But when you are looking at the gradient of a line, like in our case, when we differentiate, we actually get the actual gradient. We don't get the gradient formula, but we get the actual gradient, which is in the form of a number. So we are given the line y is equal to 2x minus 1. Now, this is where we are saying that for us to get the gradient of this line, we need to differentiate. When we differentiate a line, what we get is a value. And when we differentiate a curve, what we get is a gradient function or the gradient formula. I'll repeat. When you differentiate the equation of a straight line, what you get is a value. That value is simply the gradient. Here, when you are getting the gradient of a line, the gradient is uniform. So you don't get different gradients according to particular points on the line, because the gradient is uniform, the slope is uniform. It doesn't bend anywhere because it is a straight line. So when you get that value after differentiating, that value stands for the gradient at any point along that particular straight line. So let's differentiate. Here we have dy, we have dy dx, dy dx is equal to, now we differentiate by a formula, so this one will just give us dy dx is equal to 2. This one is a constant which will give us 0. Now this one will give us just 2. Okay, so dy dx of this straight line is 2. So it means the gradient of this straight line is 2. That's what this means. It means the gradient of this straight line is 2. It means the straight line could be this one, and as we are told, this straight line is meeting the x-axis at -1. Is meeting the y-axis at -1. So the orientation of this line is this. The y-intercept here is -1, so it is meeting the y-intercept at -1. Then we are told the gradient is 2. So this is the line that we are talking about, whose gradient is positive 2. It means it slants, the line slants upwards to the right, because actually its gradient is positive. When the gradient is positive, then it means a particular straight line slants upwards to the right. Okay, so basically this is how we do it when we are getting the gradient of a straight line. Actually, this additional statement here says, find the gradient of the line this at -1, this one does not matter. This one does not matter, Because as soon as you differentiate, you get a value. That value is actually the gradient. But when you get the gradient function, as when you are getting the gradient of a curve, you get the gradient function. That is only when you need the point. Because when you have a curve, the gradient of a curve differs according to the points according to the points of interest. So the gradient differs. Sometimes it is negative, it is 0, it is 1, like that. It differs according to at what point you are getting the gradient. But this is a straight line. The gradient is uniform. So it doesn't matter at any point, the gradient is uniform. Thank you very much.